Namaste. So welcome to this video. So today we are going to see the concept of energy and power. Okay. So concept of energy and power. Okay. So to understand, let us take a simple circuit. So consider a simple circuit. So this is my simple circuit with resistor R here. So this is resistor R, and let us say, so this is my input. Okay, so plus minus V of t is my input. Okay, so let us use a different color. So this is my current I of t. Okay, so this is the simple circuit so showed here. So now the question is, what is the power dissipated by R? So what is the power dissipated by R? Power dissipated by R. Okay, so what is this? So P of t is equal to, so V of t into I of t, right? This is the power formula. So V into I, right? So the same power can be written as, so in the different form, this is V square by R. This also be true. This also can be written as, so I square of t into R. So these are the three forms of the power so dissipated by the resistor R. So this is called power. So this is called instantaneous power. Instantaneous power. Okay. So let us go to the next slide. So let us consider for ease. Let us normalize. So let us normalize. So with respect to R, okay, and so R is equal to 1. Okay, if you take this now P of t now becomes V square of t, correct? And this is same as, so I square of t. So this is about the instant power. Okay, so please note that, so this is only true if R is equal to 1. If R is not equal to 1, so then this is not true. Okay, so this is only true if R is equal to 1 ohm. Okay, so if R is not equal to 1, then the P of t is going to be, so V square of t by R. This is same as I square of t into R. So this is if R not equal to 1 ohm. Okay, so let's go to the next slide. So we know that what is the power? So what is the relation between power and energy? So power is nothing but rate of change of energy with respect to time, right? Rate of change of energy. So this is the relation between power and energy. So now if I want energy from here, what is that I have to do? So E of t is nothing but, so this is going to be integration of P of t into dt. Okay, so the limits can be so anything. So it can have let's say, for example, t1 to t2. Okay, so in general it is going to be, so minus infinity to plus infinity. Okay, so therefore in general, if you take now, so this is for so t less than or equal to t2 less than or equal to t1 for a particular duration. So in general it is going to be, in general, so the total energy so is going to be E of t. So this is going to be minus infinity to plus infinity, so P of t into dt. So what is P of t? So P of t is going to be, this is infinity to infinity, so this is going to be V square of t into dt. Okay, so please note that, so this is only true so if r equal to 1. If r is not equal to 1, then we have to divide with r. Okay, so this is the energy E of t, right? So once the signal is given, so how to calculate this? So simple, just square the signal, take the area, so that gives rise to energy. Okay, so let us go to the next. So now actually we know that from the previous, what is P of t? So P of t is instantaneous power, right? This is instantaneous power, right? If you want to time average, if you want the average power, we need to have, so time average. Average power. What is time average power? We need to average, we need to average with respect to time. Okay, so this is minus, so let us say for example one time period, so this is P of t dt by t, right? So where the t goes to infinity, right? So this is the time average. This also can be written as, so minus t to t, so P of t dt by, so what is the time duration here? It's 2t. So therefore here the t should be into infinity, right? So depending upon this, so we have to divide here, right? So here we have t, so that the total duration is t. That's the reason why putting t here. So here the total duration is going to be 2t. So that is the reason we are putting here 2t. Okay, so this is the time average power. Now we have a special case here for a periodic signals. For periodic signals, if you have a periodic signal, then the average power is going to be, so 1 by t naught, so integral over one time period t naught, so x squared of t into dt, right? So what we are doing now, so if it is a periodic signal, so all we need to focus over only one time period, right? So that is what I have written here. So t naught is the fundamental time period. So therefore, so this is going to be, what is this? By definition, so this is going to be energy, right? Energy over one time period. So therefore this is, so E over one time period t naught by total duration t naught. So this gives the average power. So therefore, so for the periodic signals, if you want to find the power, first we need to find the energy, so divide with the t naught, so that gives rise to the average power. With this we'll stop here. So when we meet next time, so we'll solve problems on power. Okay, so till then, take care. Thank you. Namaste.